friends, welcome to the channel of Digital to Real. Today we are going to discuss about I2C operation. आज हम किसके बारे में डिस्कस करेंगे? I2C ऑपरेशन के बारे में, I2C के मैसेज के बारे में, I2C के फ्रेम्स के बारे में, डेटा फ्रेम, एड्रेस फ्रेम, स्टार्ट कंडीशन, एक्नॉलेजमेंट, स्टॉप कंडीशन, जो भी डेटा लाइंस है, SDL लाइंस एंड SCL लाइंस, इनके बारे में हम डिस्कस करेंगे. ठीक है, लेट्स स्टार्ट. सो दिस इज द मैसेज ऑफ द I2C. द मैसेज अवेलेबल एज द SDL line, serial data line with respect to the clock, that is the SCL line. Okay, so first in the message it comes the start condition. After the start condition is sent, then 7 or 10 bits address frame is sent, address of the slave, which the I2C master want to communicate with. So the addressing mode we know, it can be 7-bit addressing or 10-bit addressing. Okay, so after the start, address frame is sent. After the address frame is sent, we send the read or write bit. Okay, read or write bit. That means that when the write bit is 0 or read or write bit, this particular bit is 0, that means that I intend or the I2C master intend to write into the slave. If it is 1, that means that I2C master is requesting the slave to send the data. Okay. After read and write bit, what is sent is the ACK and NACK bit, that is the acknowledgement and no acknowledgement bit. After the ACK and NACK bit, what is sent is 8-bit data frame. It is the data frame that is being sent. After the data frame is sent, what is sent is ACK and NACK bit, acknowledgement and non-acknowledgement bit, same as this ACK and NACK bit. Okay, ACK and NACK bit is sent after the address frame and read-write bit. It is also being sent after every data frame of 8-bit is sent, ACK or non-ACK bit is sent. And at last is come the stop condition. Here I have shown only one data frame, but there can be multiple data frame. Means after the ACK and NACK bit, there would be again another set of data frame of bit 8, number of bits 8. Then again ACK and NACK bit would be sent. As long as you want to send the data frame, you can keep on sending, but at last there would be the stop condition. Okay. Now let us discuss about the start condition. अब हम start condition के बारे में discuss करेंगे. Start कौन सा है? ये start condition है. Okay. The SDL line switches from a high voltage level to a low voltage level before SCL line switches from high to low. तो आपके पास 2 बस लाइन्स हैं, क्योंकि बाई डायरेक्शनल एंड 2 बस लाइन्स जो हमारे पास है. So I2C has 2 bus lines and it is bidirectional in nature. The SDA is bidirectional. Okay. So in the start condition, when the SDA line goes from 1 to 0, okay, at that time SCL should be high and it would go to 0 after some time. Okay, that means SDA line switches from high to low level, that is 1 to 0 is happening before means SCL lines, before the SCL line make the transition from high to low. So this is the specific condition for the start. Now we will discuss about the stop condition. The SDL line switches from a low level to a high voltage, means SDA making the transition from 0 to 1. Okay, when it is happening after SCL line switches from low to high level. Here is the SCL line. First SCL line make the transition from 0 to 1. After some time the SDL line make the transition from 0 to 1. This is the stop condition. SDA goes high after SCL. Okay. Now address frame. We have 7-bit addressing mode and 10-bit addressing mode with respect to I2C bus protocol. So A7 or 10 bit means address 7 or 10 bit sequence unique to each slave. Means a master when it want to communicate with a slave, because in I2C we can have multiple master, we can have multiple slave. We can have single master, we can have multiple slave. Okay. So the communication is happening between the multiple peripherals. So when a master want to transfer data or read data from a slave, it needs to address it. It needs to send the address of the specific slave. Every slave attached will have a specific address, and the master will send address for the specific slave it want to interact with. So it will send the address in that address frame. So a A7 or 10 bit sequence unique to each slave is having a unique address that identifies the slave. That address identifies the slave when the master wants to talk to it. So whenever the master wants to talk to a particular slave, it needs to send the address frame. The address frame can be of 7 bit, it can be of 10 bit. Read-write bit. Okay, now we will discuss about the read-write bit. A single bit specifying whether the master is sending data to the slave, low voltage level, or requesting data from the slave, high voltage level. So read-write bit is a single bit. Okay. So when it is low, that means when it is 0, that means master is sending data to the slave. It is writing data into the slave. And when it is high, that means that it is requesting data from the slave. That means it is reading data from the slave. ACK, NACK bit. ACK bit or NACK bit. Same bit does the work of ACK and NACK. Okay. Each frame in a message is followed by an acknowledgement or non-acknowledgement bit. So ACK stands for acknowledgement and NACK stands for non-acknowledgement bit. So each frame in a message. So when you send one frame, be it address frame, then read write read, after that you send a ACK or NACK bit. Even after the data frame, you send a ACK or NACK bit. Okay. So if an address frame or data frame was successfully received, an ACK bit is returned to the sender from the receiving device. So when the address frame is sent from the master to the slave, obviously slave will send some acknowledgement to tell, yes, I have received the address. So this bit does the work. Or I have not received the address, that also is done by the same bit. Okay, even after sending the data frame, this particular bit tells, yes, I have received the data, or it says I have not received the data. So A is equal to, what does the A means? So acknowledgement, SDA low, means when the SDA low, when the SDA line is low, that means that I have received the acknowledgement that yes, address frame or data frame is received. A bar means SDA high, means not acknowledged, or non-acknowledgement means if the SDA line is high, that means no, the data has not received at the slave. No, the address has not been properly sent to the slave. Sending a bit. So I am sending a bit. So be it the address bit or be it the data bit. So here is the SDA line and here is the SCL line. You see the SCL line is making the transition from 0 to 1 here. And at this time the SDA line is stable, at stable state. So whatever is available during this rising age will get sampled. Whatever is available at the SDA line will get sampled for the SCL line when it make the transition from 0 to 1. So it is being said that SDA is sampled by receiver, that is SDA line is sampled by the slave on the rising edge of the SCL. Okay. So SCL of the master and slave is tied. SDA of the master and slave is tied. SDA line is bidirectional in nature. SCL line is unidirectional, sent from master to slave. Okay. Now the SDA must be constant when SCL is high. So SDA value must be constant. This is constant when the 0 to 1 transition is happening. Okay, and this condition is not valid for stop and start condition. Exception is start or stop condition. Means for start and stop condition, already whatever is the condition for SDA and SCL line I have mentioned. Here is the SDA line and here is the SCL line. Okay, SDA line, data is sent here in this particular line, and SCL line, clock is sent in this particular line. Okay, you see, this is the start condition. SDA line making the transition to 0 from one position. At that time SCL line was high. After some time SCL line made the transition from 1 to 0. So SDA line made the transition before SCL line made the transition from 1 to 0. Then address bits are being sent. A6, A5, A4, A3, A2, A1, A0. 7-bit address mode. So address bits have been set. You see the clock. This is the clock. When the transition is happening for 0 to 1 for the clock, at that time the address bits are stable. You see. So they are being sampled properly. After address bit is sent, what it is sent is that read write bit. Read write bit. And this is also the clock with respect to SCL line. So read write bit is sampled. If it is low, that means write condition. If it is high, that means read condition. Okay, that I have written. 1 means controller is requesting data. That is master is requesting data, read condition. Or 0 means controller is sending data, means master is sending data. After this condition, what comes? It is the ACK or NACK bit. It is low. That means data has been or address has been properly sent and it is being acknowledged. 0 means acknowledgement, 1 means no acknowledgement. ACK and NACK bit, a 1 in this position indicates that the address peripheral, that means slave, did not respond. So if it is 1, data has not been properly sent, no acknowledgement. If it is 0, that means acknowledgement has happened. Now here is the data frame that has been sent. Okay, this is after the acknowledgement received. And for data frames also, you see, for positive edge of the SCL line, data is constant. They are stable when the transition is happening here, 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 here. Whenever the transition happening, at that time data is stable. So D7 to D0, the data frame of 8 bits have been sent. After that, again acknowledgement is sent. So 0 means data has been properly being sent to the slave. Okay, after that clock is low. So this particular value at the data line doesn't matter. But after that stop condition is there. Means after the SCL line made from 0 to 1 transition, the SDA line also made transition from 0 to 1. This condition is the stop condition. SDA goes high after SCL. If you like this video of I2C operation, please share it to your friends. Please subscribe the channel and have a very nice day.